All right, guys, DNS exam number 1, problem number 16. So, the issue that we seem to have with this problem every single year is not quite recognizing what style of problem it is. If we read it there, they gave us the definition of f of x explicitly. They told us the value of f of negative 1, and then they told us that g of x was defined as the inverse function of f. So when they ask us for the value of g prime of 0, we need to recognize this here as a problem that we did at the very end of chapter 3 when it dealt with derivatives of inverse functions. So I think this is from section 3.8, if I'm not mistaken. So if you guys will notice, right away I went ahead and made a t-chart out of this. And usually as soon as I do that, then people tend to go, oh, it's one of those problems. But they have a hard time remembering that on their own. So we have the explicit definition of f of x, and we simply know that g is the inverse of f. We were given a value right here that f of negative 1 is 0, and from that, knowing that g and f are inverses, we now know that g of 0 is equal to negative 1. And that becomes the key to this problem, because eventually we want to find g prime of 0, so knowing the value of g of 0 is essential. Now, going back over here into the f column, if we have an explicit definition of f of x, we can find f prime of x. Just taking the derivative of that, we're going to get a 3x squared plus a 6x. And the mistake that most people make here is they want to try to take the 0 from the g prime that we eventually need and plug them in right here. But that 0 is only a relevant x value over here on the right when we're talking about g, which is the inverse of f. The only x value that's relevant over here in f land on the left is negative 1. So we take our general derivative, evaluate it at negative 1, and get negative 3 for the value of that derivative. Then, the main idea from this section here is that the derivative of the inverse of a function at its sister point, 0, negative 1, instead of negative 1, 0, is always going to be the reciprocal of this value right here. So taking the reciprocal of negative 3 gets us negative 1/3, and the correct answer is A.